Welcome everyone. In this video, we're going to be looking at this question. It's a Cambridge question. It's an entrance test question. It says that we should find the sum of the real solutions of the equation as we have on the screen. So, what are we asked to do here? We are being asked to get the solutions. Definitely the solutions will be more than one. So we're going to be getting about 2 or more solutions we don't know yet until we solve. So for instance, if the solutions are 2, if we have 2 answers, let's say 3 and 4, then we are going to be summing the solutions together. So which is going to be 3 plus 4, and the final answer is going to give us 7. I'm not saying the solutions are 3 and 4. But once we begin to solve, we're going to be getting the solutions. Now let's quickly go into the question fully. So the first thing we're going to be doing here is we're going to be splitting this. We're going to be splitting this. The square root of 3 raised to the power of x plus 4. Don't forget, one of the laws of indices says that when we have a raised to the power of b multiplying a raised to the power of c, we can add the power, which is going to be a raised to the power of b plus c, and vice versa. If we have something like this, we can also get this, and that's what we're going to be applying. We're going to be disarming the square root of x, square root of 3 raised to the power of x plus 4. So it's going to be giving us 3 raised to the power of x, 3 raised to the power of x minus the square root of 3 raised to the power of x multiplying the square root of 3 raised to the power of 4, then plus 20 equal to 0. So from here we're going to be solving the square root of 3 raised to the power of 4 to get an actual number. So of course it becomes 3 raised to the power of x minus, then we have the square root of 3 raised to the power of x multiplying. So instead of me writing the square root of 3, I can write it as, when I have the square root of a, which can also be written as a raised to the power of 1 over 2. So you can turn square root into indices notation, into an exponent notation. So which is going to become 3 raised to the power of 1 over 2, then everything raised to the power of 4 again, because we have the power of 4 already, then plus 20 equal to 0. And of course, don't forget that one of the laws of indices says when we have a raised to the power of b in bracket, then raised to the power of c outside, we need to multiply the powers. It's going to become a raised to the power of b multiplied by c, and that's going to be a raised to the power of bc, and that's what we're going to be applying here. So we're going to be having 3 raised to the power of x minus the square root of 3 raised to the power of x times, then I'm going to be having 3 raised to the power of 4 times 1 over 2, then plus 20 equal to 0. Of course, I'm going to be multiplying 4 times 1 over 2. So in turn, everything is going to be giving us 3 raised to the power of x minus the square root of 3 square root of 3 raised to the power of x. Of course, we're still going to be doing something to square root of 3 raised to the power of x, but I want us to take it one after the other. Then times, and we have 3 raised to the power of 2. Of course, we have 2 here 1, then we have 2 here 2, and that's why we are having 3 raised to the power of 2, and plus 20 equal to 0. Then we progress also from there. So we're going to be having 3 raised to the power of x minus the square root of 3 raised to the power of x multiplying by 9. Then we have plus 20 equal to 0. Of course, I'm going to be writing 9 before square root of 3 raised to the power of x. I love it that way. So let me rearrange. So I'll be having 3 raised to the power of x minus 9 multiplying the square root of 3 raised to the power of x plus 20 equal to 0. Now let's quickly find something to do about this. Square root of 3 raised to the power of x. Don't forget, we just established how that we can have the square root of a to be the same thing as a raised to the power of 1 over 2. So we can turn square root into exponent notation. And that's what we're going to be doing here. So we'll be having 3 raised to the power of x minus 9 times, then I'll be having 3 raised to the power of 1 over 2, then multiply by x, which is another power, then plus 20 equal to 0. And of course, when we have a raised to the power of b, then raised to the power of c outside the bracket, so it's going to be equal to a raised to the power of b times c, that's bc. So you're going to be multiplying the powers when you have situation like this, and that's what we're going to be doing. So we'll be having 3 raised to the power of x minus 9 times 3 raised to the power of 1 over 2 times x times x plus 20 equal to 0. So we'll be having altogether 3 raised to the power of x minus 9 times 3 raised to the power of x over 2 plus 20 equal to 0. Now, when we have a situation like this, we need to be very, very watchful. There is a relationship between 3 here and also 3 here. So there is a relationship. So when you have situation like this, so 3 and 3, they are having the same, they are having a relationship. Then we need to check the power. Anytime you discover that the power of 1, which is x over 2, which is the power of the 3 here, then there's also a relationship with the power here, which is x. So when one of them is twice the other, we can represent it using a particular letter. So instead of me writing, it's going to be too complicated like this. I will say, I can say, let this be equal to u. I can write it as u. I can say, let 3 raised to the power of x over 2, that is this, to be equal to u. And if this equal to u, it means 3 raised to the power of x will be equal to u squared. You can prove it. Now I have 3 raised to the power of x is equal to u squared, and I have 3 raised to the power of x over 2 equal to u. So let me quickly prove it. So it means if I have 3 raised to the power of x over 2, then that's u. Then squaring it, what is it going to give us? It's going to give us 3 raised to the power of x over 2 times 2. Of course, 2 and 2 cancel out to give us 3 raised to the power of x. So you can see 3 raised to the power of x, the power, which is x, is double of this one, whose power is x over 2. And as such, we can use this. Replace 3 raised to the power of x as u squared, while we replace 3 raised to the power of x over 2 as u. And that's what we are going to be doing now. So we have this. Now we are going to be representing this as u. So let's u equal to 3 raised to the power of x over 2 now. So we have u raised to the power of 2, we've been able to establish this, minus 9 multiplied by u, 9u, plus 20 equal to 0. And as you can see, this is a quadratic equation. So we can easily solve this quadratic equation by getting the factors of 20 such that when you add them together, they're going to give us minus 9 here. So what are the factors of 20 such that when you add them together, it's going to give you minus 9? That's minus 5 and minus 4. Because minus 5 times minus 4, they are definitely going to give me plus 20. And when you say minus 5, then plus minus 4, it will definitely give me minus 9. That's what we're going to be doing. So we have u squared minus 5u, then minus 4u, then plus 20 equal to 0. Of course, we are going to be grouping. So we have this and this. We have u, open bracket, u minus 5. Then 4 is also common here. So we have minus 4 into bracket, u minus 5 again, equal to 0. And of course, we have u minus 5 and u minus 4 equal to 0. So it means either u minus 5 equal to 0, or we say u minus 4 equal to 0. Of course, from here we know that one of the solutions is that u equal to 5 or u equal to 4. So we'll be able to get the two values of u, which are 5 and 4, but that is not what we need. What we are being asked to get is the values of x, such that when you add them together, what is going to be the result? Now let's quickly look into that. Since we already know that u has a value, an initial value, and the value is u equal to 3 raised to the power of x over 2. So we are going to be replacing that now. So let's quickly get the two values. We have u equal to 5 and u equal to 4. So you have u equal to 5, and at the same time we know that u equal to 4. Now when u equal to 5, we know that u is also 3 raised to the power of x over 2. So we can say 3 raised to the power of x over 2 equal to 5. And of course we can raise to what? Both of them to logarithm. I can use base 10, and I can use base 3. It's better I use base 3 here. So if I raise the both to logarithm of base 3, I'll be having the logarithm of base 3, then we have the number here, which is 3 raised to the power of x over 2 equal to the logarithm of base 3. Of course, we have 5. Don't forget, one of the laws of logarithm is when you have log of a particular base, let's say base A, then we have B. Then if B is having a power or is having an exponent, which is C, we can in turn bring the C to this side, which becomes C log, we have base A, then we have B, like this. And that's what I'm going to be doing. So x over 2 is the power, is the exponent. So I'm going to be bringing x over 2. So we have x over 2 log 3, then we have 3. So which is equal to log 5 base 3. And of course, one of the laws of logarithm is also how that if you have the log of a particular base, say A, and the number is also A, so if they are both the same like this, the result is 1. So of course, log 3 base 3 would give us 1. So we have x over 2 multiplied by 1 equal to log 5 base 3. And of course, I don't need to stress myself too much. All I just need to do is multiply through by 2. So multiplying through by 2, we know that x equal to 2 log 5 base 3. That's one of the solutions for our x. Now let's get the other solution. The other solution, using u equal to 4. So when u equal to 4, when u equal to 4, we know that 3 raised to the power of x over 2 equal to 4. And from there we can raise both to the logarithm of base 3. So we have logarithm of base 3, then we have 3 raised to the power of x over 2 equal to logarithm of base 3 here, then we have 4. Of course, using the same approach, we have x over 2 log, we have 3 base 3 equal to log 4 base 3. And of course, we know that log 3 base 3 would definitely give us 1. We've been able to establish that. So we have x over 2 equal to log 4 base 3. Of course, we multiply through by 2. So we're going to be having x equal to log 2 log 4 base 3. So we've gotten the two values of x. One of them is 2 log 5 base 3 and the second one is 2 log 4 base 3. But that's not the question. Don't forget, the question says find the sum of the real solutions of the equation. So we are going to be adding the two answers that we have gotten together. So I'm going to be praying that we get one of the answers here. Now let's quickly do that. We know that one of the answers is x equal to 2 log 5 base 3. And the other one is x equal to 2 log 4 base 3. So we're going to be adding 2 log 5 base 3 plus 2 log 4 base 3 together. Let's quickly do that. So we have 2 log 5 base 3 plus 2 log 4 base 3. So both are having the same base and there is addition. So it means we are going to be applying one of the laws of logarithm here. So we have 2, which is common. So it becomes 2, then log 5 base 3 plus log 4 base 3. So since they are both having the same base, I will write 2 in the bracket. They have log, we have base 3, we have 5 times 4. Please don't forget when we have log A plus log B, in as much as they are both having the same base. So it's going to be equal to log A multiplying B. And that's what I have just done here. So I have log 5 plus log 4 sharing the same base becomes log 5 times 4 with base 3. And of course, it's going to be equal to 2 log 20, because 5 times 4 is 20. Then we have base 3. So the answer is this, 2 log 20 base 3. As you can see, very simple. I will be sharing more videos on questions like this. Please do well to follow, to share, and to comment. You are great.